In the AWS Developers Podcast, we're talking about in-memory database. Good morning, good afternoon. Thank you for downloading the AWS Developers Podcast. We are available, you know that, on all good podcast applications, Apple Podcasts, Deezer, Spotify, on YouTube, just the sound, not the video. Please leave a feedback, leave comments, put a little thumbs up or a little star. We read your feedback whenever we can find them, and please subscribe so you can receive new episodes every Friday morning, wherever you are on this planet. Today, as I mentioned in the introduction, we're going to talk about in-memory database. Why is it useful for developers? And I have the pleasure to welcome Lakshmi Peri, your senior specialist solution architect at AWS, specialist in in-memory database, in-memory services, because we have more than one. It's not just ElastiCache. When I joined AWS many years ago, it was only ElastiCache, so it was pretty much easy. The landscape is a bit larger. What are the different services? What is the landscape of memory databases at AWS?
Absolutely. Thank you for welcoming me onto this podcast. A modern data strategy, especially when you're migrating to cloud, kind of moves towards an infrastructure that enables you to have scale, but then there is no one size fits all, which is why we have the complete set of relational and purpose-built databases. And when you talk about speed, that's where you would bring in the in-memory services, because in-memory or anything in-memory gives you the most fast access. Now, when we talk about the in-memory managed solutions at AWS, we kind of talk about it on a durability spectrum. So we have two services, ElastiCache and MemoryDB. But then ElastiCache supports two different engines, actually three, that would kind of be on the scale of durability spectrum. So we talk about ElastiCache for Memcached, which is fully ephemeral, and then ElastiCache with the support for the Redis, OSs, or the Valkey engines, which is the semi-durable. And then finally, we have MemoryDB, which is compatible with the Redis OSs and Valkey, which is uses the multi-AZ transaction log and provides like a high durability.
So, in a nutshell, the idea is to reduce latency for application. When an application tries to access data, it's to access data with lower latency. And the three options that our customers, developers have between ElastiCache, Memcached, ElastiCache, Redis open source / Valkey, or MemoryDB, the main difference is the durability of the data. So we are going to enter into the details of that. But I said when I started at AWS, there was only ElastiCache, and I think it was only Memcached at the time, and the purpose of this service was to fit in between the application and the database. So the pattern was, as a developer, I tried to search for data in the database. In the cache first. It's not there. So I go and fetch into the database and I store the data in the cache for later access. So it was really a service for application developer to speed up the request on the database. If we start with the historical point of view.
Yes. So ElastiCache primarily is to speed up the database and the application performance. It can scale to millions of operations with microsecond response time. ElastiCache also offers like the enhanced security and reliability when using with the open source products like Redis OSs or Valkey. In addition to what it's really famous for, the real-time data caching, ElastiCache is also the choice of engine for service for storing ephemeral session stores, like if you're using quickly to personalize your gaming, e-commerce, or any applications which you need microsecond response times, or if you want to simplify your application development with the built-in data structures in Redis OSs or Valkey by using for readable, you could also use ElastiCache for these applications.
So typical example, you mentioned retail. That's something we know quite well at Amazon, at AWS. It's retail. If I want to implement my website session, simply just that, or a shopping basket, an ephemeral shopping basket, instead of tapping into a relational database with the extra latency that might come with strong concurrency and strong relational transactional verification, most application developers today choose like an in-memory database for speed. What about DynamoDB? I know it's not in memory, but where should I use one or the other?
No, that's a very good question. So ElastiCache in specifically is a semi-durable engine. So when you want to have single-digit millisecond, microsecond latencies, and your data is semi-durable in nature, you have ephemeral data storage, and this is not you want to worry about the persistence of your data, then ElastiCache with its lowest latency would be the engine of choice.
What about availability? Because I already started Memcached instance on my laptop. It's really bound to one single machine. So I guess that for availability, we need to have multiple instances. This means a cluster across availability zone, and this is where the fun starts.
Absolutely. So ElastiCache with Memcached and Redis engines actually deliver up to 4 nines of high availability, which kind of all your modern data applications need. And you mentioned a very important, interesting point on how do I set up an instance, start an instance. ElastiCache also supports or kind of makes the entire provisioning management very easy. You can quickly get started with ElastiCache serverless. You can simply create like a new serverless cache within a minute and access it from your console, the AWS CLI. And if you're designing your own clusters, you need that level of flexibility. That's also an option with self-designed clusters. But if you want to, both of them are fully managed, but we can automate time-consuming management tasks, such as capacity planning, software patch management, all of this, and even kind of simplify the underlying instance management with serverless. So you kind of rely more on your application development and will not worry about failure detection, recovery, software patching, all of that.
That's my answer when people are telling me, hey, AWS is charging for open source services that are for free. I say, no, we are not charging for the open source service. It's for the installation, the patching, the backup, everything that you would have to do by yourself if you install that on EC2 or other machines by yourself. Can we say that ElastiCache is to Memcached and Redis open source what RDS is to MySQL and Postgres? I mean, it's a fully managed version. It allows user to not have to download the package, install the package, configure the cluster, do the monitoring, the backup, the patching, and all the things that you mentioned.
Yeah, absolutely. It's a fully managed service. So all the time-consuming management activities are fully kind of automated with capacity planning. When it comes to serverless, even the minor version upgrades, the performance enhancements, security patches are all automatically applied with no configuration required and without any application disruption.
And what does that mean from my code? If I'm a Java developer or .NET developer, I can use the standard libraries from Memcached, or there is a special SDK from AWS?
No, you can actually use standard libraries we support all the open source client libraries with ElastiCache. So if you're a Java developer or a Python developer or even a PHP developer, the open source client libraries that you would use if you're running your instances on EC2 are also supported with ElastiCache and ElastiCache serverless. With serverless, we kind of also add the built-in security aspect of it. So when you're connecting your standard node-based instances, you might want to do no TLS, but with serverless, we kind of enforce TLS. So you're kind of having that additional security layer.
It's been a couple of times that you mentioned serverless. Let's go into that. Traditionally, I have to choose host, a bit like RDS. I have to choose the memory and the CPU size of my host, which are underlying EC2 instance. At the end, there is no magic. What is this serverless option?
Serverless 10, I think there's actually two high level points that makes serverless the kind of easier place to get started with ElastiCache, especially from a developer standpoint. Number one, you have a highly available cache in under a minute without infrastructure provisioning or configuration. You can create this with any of the tools that you kind of today use. Like, if you're using CloudFormation or CLI, or if you're using third-party tools like Terraform, all of them, you can just create the way you create instance space without specifying any instances. And the biggest advantage when you start off as a developer, you may or may not know what your end cache size or the dataset size would be at the end. So it removes the complexity of, capacity planning and allows you to not over provision or under provision. Because serverless continuously monitors how you're kind of storing the data. It monitors your compute, memory, network, and it instantly scales horizontally and vertically to kind of meet your demand. With at reInvent 2024, we've added furthermore improvements with the help of Valkey 8 into serverless that helps you scale. Like, I think the most recent benchmarks that we run helps you scale from 0 to 5 million requests per second in under 10 minutes.
Wow. What are the key metrics for pricing for the serverless edition? Because I guess for the traditional, it's the host per hour or per minute, but for the serverless,
it's a pay-per-use billing model. So primarily, you do not have to worry about how quickly ElastiCache serverless scales back on capacity. Say you have a workload that's very spiky in pattern. You have a few hours of a day where you see that grow from maybe 10 gig to 100 gig, or even have a peak load of 30,000 or 300,000 requests per second. But then it scales down towards the end of the day to like 10 gig or even lower. You only pay for the data that you store and then the compute for your applications. As long as your data is scaled down, as long as your computes are down, you're not going to pay for whatever's the underlying hardware provisioned. You don't actually have to worry about self-designed cluster. Oh, now that my traffic's going to go down, I have to bring down all of this. So I'm not paying for additional provision storage. And I know we talked about Valkey. With ElastiCache for Valkey, you can have a cache as low as like a $6 per month. And overall, we reduced the pricing on ElastiCache serverless by 33% in comparison to ElastiCache Redis OSS.
That's a big price reduction, and that's something our customer always love. What would be your guidance when to go for serverless or the non-serverless, the traditional host-based capacity? Is it when traffic is unpredictable or very spiky, and then serverless is probably the better pricing option, and the host-based when we know exactly how much capacity we need?
Yes, so that's all the customers typically, even from a developer standpoint, you kind of want to start off with maybe serverless, understand your traffic patterns, understand your cache patterns, understand how much you're storing, how much of your relational or persistent data stores you're going to put in your cache. And once you know that you would have like a more stable workload, not a spiky workload in pattern, then you can go to like a self-designed clusters, because now you know what your data set size is, what your throughput is. You can accurately design your clusters. But like if you are starting off for a new application, building multiple microservices, and at the start you're not you're not clear on how the pattern would be, then start off with ElastiCache serverless. Also another point that you mentioned is, of course, the spiky patterns. Like cache, if you're storing it for session stores, leaderboards, you only want it to be active during a specific time of the day, or a few hours in a day, or even 8 hours, sort of the 24 hours in a day that it's active. then if you know that this is your peak time, instead of going through an effort of scaling up manually, scaling down manually at the end of the day, you could just pick serverless so that it automatically helps you scale up, scale down during your performance in line with your traffic patterns.
I like the way things are very similar in between AWS services. If you look at DynamoDB, on-demand throughput versus provisions throughput, it's exactly the same story. If you look at a Lambda compute versus ECS, EKS containers, it's exactly the same story. When you don't know, when it's very spiky, when it's unpredictable, when you start, go serverless, and then maybe for some application, for some patterns, it might be more cost effective to go to a more traditional server-based type of deployment. And it's the same here with ElastiCache. When we deploy a new version of the application, many developers are using like blue-green types of patterns. Like they have the two stack, the old version and the new version running in parallel for a short period of time. But with in-memory in-memory cache, in that case, ElastiCache, it means that I'm starting with an empty cache. Are there strategies to take a copy of the old cache to rehydrate the cache, as we said, to ensure that the application is not starting with an empty in-memory cache?
Yeah, absolutely. So there's ways to create a cache. When you're creating a cache, you can create it from an empty cache, if that's kind of wherein you're adding the cache fresh to your relational database, and then you can kind of create your Aurora cluster, create an ElastiCache instance to then just start populating the data into the cache. Say you already have a cache, then you're just bringing up or setting up in a new environment or in a different environment. You know what your data is and you want to pre-populate some of that, then you can always take a backup RDB file. Those are the backup files. And when you take the backup, you can create a new cache with that backup file itself. And then you want to do, like, you're already running cache, maybe you're running ElastiCache, not running ElastiCache, but maybe you're running like a Redis OSS or Valkey on EC2, and now it's time that you wanted to maybe just move to a managed service. We have options. We have options for migration, so you can look at the same backup and restore option, or there's an online migration API that helps you move your cache data from EC2 instances, the Redis or Valkey EC2, to ElastiCache.
So far we talk about ElastiCache with two modes, memcached, that originally came from PHP, if I remember well, and Redis open source, which is like a key value data store, and the new version of Valkey. You mentioned Valkey several times already. Maybe we can kick that out, that subject out, and explain what is Valkey. It's a new open source version of Redis, started from the old Redis open source.
Yes, so Valkey is the open source in-memory key value store. So in March of 2024, Redis as a company has decided that they want to change the licensing model of the then open source Redis, which has a very active community, but they've decided that the future versions of Redis will be under a different licensing model. And the community that were active contributors to the Redis open source project wanted to still have something open source, like an in-memory key value store. And the community actually created an open source Valkey project. One of the key co-creators is Madeline Olson from AWS, but they started this off as a fork from the then open source version, Redis OSS 7.2. It's fully compatible with the Redis OSS 7.2, but it's backed by the Linux Software Foundation with an open governance, so the project will be open source forever. and it's maintained by the same individuals that were previously building, contributing to the Redis, then open source. And we have, I think, 2 out of the 5 previous maintainers, and then a very highly active top contributors that are now also contributing to the Valkey project. And it's backed by industry leaders, including AWS, have identified Valkey as the next key value data store, and they kind of supported are moving towards Valkey OSS, like industry leaders like Google, Snapchat, Ali Cloud, Ericsson, to name a
Big
few.
names, really big names. So if I'm starting a new application today, you would recommend using the Valkey engine on ElastiCache, and the Redis open source version on ElastiCache is still there to maintain existing application for existing customer. That's my mental model of it. Is this correct?
Absolutely, because if you're already running ElastiCache with Redis, we will still continue to support it. We haven't had any end of life announcements on Redis version 5, 6, and even 7 that's running on ElastiCache. So we will still continue to support it. But then if you're starting off a new application, then would strongly recommend looking at Valkey. And because of the track record of the contributors and their track record of having stable contributions, there's a lot of enhancements that went into Valkey. The project started as the first release candidate came out in April as 7.2, and then there's Valkey 8 that was released, and ElastiCache added support for Valkey 7.2 and Valkey 8 last year. MemoryDB has support for Valkey 7.2. So there's a lot of enhancements. One of the key enhancements that are coming to the Valkey engine is also improved performance. There's better reliability and there's higher memory efficiency. So the same clusters that you would deploy, if you change your engine from Redis OSS to Valkey, you would see 20% improvement in memory efficiency. And when we've introduced Valkey, because of all the contributions we've made in terms of the performance gain, we've contributed back with the price reduction. So there's also between the Redis OSS versus Valkey engines, depending upon the model you choose, whether you're running ElastiCache node-based or ElastiCache serverless or MemoryDB, you would see anywhere from 20 to up to 35% price reductions running Valkey with ElastiCache. So
it's a no-brainer. Is there a way to export an ElastiCache in-memory database from Redis open source to Valkey? They are compatible, so I guess the file format is the same.
Oh yeah, absolutely. So it's when you're moving from ElastiCache Redis OSS to Valkey, I wouldn't actually call it a migration. It's more of an in-place upgrade. So we made the APIs are all compatible. It's a fork, and it started off as a fork. So we kind of kept everything from a config, API, protocol, client, libraries, pretty much the same. So it's more of an in-place engine upgrade per se. Like how you're moving from 5 to 6 to 7, you move from Redis OSS 7.2 to even Valkey 8. You can even move from Redis 6 or Redis 5 to Valkey 8. So essentially, with any engine upgrades, it's more of an in-place movement, right? We bring in new nodes or new shards, and then we swap them out. So you have the same endpoint, you have the same kind of seamless experience of online upgrade experience that you would see with any engine upgrades on AWS.
So this is the first option we talk about amongst AWS services, ElastiCache with the 2 different engines, Memcached and Redis/Valkey. I consider them still as one because it's roughly the same, the same origin at least. Use case, as you said, is the durability, short duration storage, typically for a cache, for a web session, maybe for a shopping basket if you don't want to keep the shopping basket for months. But if we shut down the cluster, the data are gone. There is no disk durability. But or maybe there is because you said semi-durable. So there is an option to store things on disk?
Yes, absolutely. So MemoryDB, I would actually not call it like a disk-based, but it is the durable in-memory database.
So that's another service, MemoryDB.
Yes.
Okay.
Yes, yes, it is another service. It is Valkey and Redis OS compatible, but then it gives you zero data loss protection, or it's in-memory database service that it can deliver the ultra-fast performance. So if you want to have what you just mentioned, high speed, low latency, but then also want to make it persistent, then MemoryDB can be your choice of database. It's compatible with Valkey and Redis OS. So you're basically using the same data structures, APIs, commands that you already use today. With MemoryDB, it's still stored in memory, so you have the microsecond read and single-digit millisecond write latency, but MemoryDB also stores the data durably across multiple availability zones using a distributed transaction log feature. So it enables for fast failover, database recovery, and node restarts. So it delivers both the in-memory performance and the multi-easy durability. It's kind of the similar technology we use with S3 Dynamo. But
the journal, you mean? The distributed journal, you mean?
Yes,
that's the same technology that we share. Yeah.
Correct. The distributed transaction log. And yes, so the difference here is you're having an in-memory performance, very high performance, because now your reads and writes are still single-digit milliseconds, and the reads are still microseconds. So sometimes some of these are scenarios where you have a database, but the database is only there just as an insurance policy. You can completely remove that database plus cache architecture with just having MemoryDB. So
what's the catch there? If I have it looks like I have best of both worlds. I have the extra low latency from in-memory read and writes, and the safety with the durability of my journals and my data being written to a disk storage. So why customers are still using a relational database at all on DynamoDB?
Depending upon, at the end of the day, it's all storing in memory. So memory is not really the cheapest option in the market. But if you need the high performance, and you would want everything to be in memory for durable leaderboards or durable session stores, then of course MemoryDB can be your choice of database. Of course, if you're storing, also when you're storing huge terabytes and petabytes of data, then you also want to have the persistence and then the scale that other RDS or Dynamo can offer. But if you're looking for really an in-memories the performance, then you have MemoryDB as your choice of options. There's no one size fits all.
And it's not an analytics engine. If you have terabytes of data to analyze, in MemoryDB is not the option. In terms of cost, that's certainly not a good idea. Look at Redshift for that, for example. And that's one of the things our customer like about AWS is the choice in terms of database. You have graph structure, then you have Neptune, you have extremely low latency, durable key value. You have DynamoDB, memory latency, in-memory type of latency, then MemoryDB, and of course everything in between with relational database, Aurora, and all the others. What are the key features or the key capabilities, the key benefits for developer of using a MemoryDB? Did we summarize them all? It's the low latency plus the durability. It's available across multiple AV as well.
Yeah, no, absolutely. So from a developer standpoint, one other kind of thing that is really important when you are architecting applications is you also have to look for enabling applications with high availability. And then with a single region, you get an availability of 4 nines. But then what happens if there are disruptions in your region? You cannot let your application go down for these application disruptions in a single region. So MemoryDB offers a multi-region active configuration. So it enables you building applications with up to 5 nines availability. Again, you still have the local microsecond read and write responses. You have eventual consistency across regions, but you have now, even whether you're using it for disaster recovery or whether you have 2 active regions that you want to write to, MemoryDB multi-region can support you to kind of scale up your applications across region and have the 5 nines availability.
As a senior solution architect, specialist solution architect, you are working with the biggest and the most demanding customer on the planet. What are the typical use cases you see for in MemoryDB?
MemoryDB, especially if there are customers that are building within their, not a monolithic and then kind of moving towards microservices application patterns. And then you have applications that need, between multiple applications, there is a kind of a database structure in memory, real-time database structures that you would need. MemoryDB would be a great choice. Sometimes customers use it for like a durable cache, durable session store. In other scenarios, they use it as a real-time database for their events. Their real-time events are coming from being streamed from Kafka or between applications. So all of these scenarios, MemoryDB would be like a common application that database that we've seen customers select. It also has, over the years that we've seen, it also has added with all the kind of innovations that we've seen in the generative AI space. Or we've kind of seen a lot of databases add the functionality of vector search. So MemoryDB delivers the fastest vector search performance on AWS. So you can store your vectors. So vectors kind of are now your another data type in addition to sets, strings, hashes, varchar that you store in RDS. And MemoryDB allows you to store these vectors into whether it's a hash or a JSON data structures. And it's well suited where performance is kind of the important selection criteria. So you can use it for vector search to power your real-time machine learning or generative AI applications.
Yeah, for retrieval augmented generation type of workflow, we can store the vectors and the snippets of text in in-memory database, and it is able to compute the distance between 2 vectors, so we can search by proximity directly. There is a new data, or maybe it's not new, but a few years ago, data type as well for the GPS coordinates, latitude, longitude. So is it a use case you're seeing as well, like a geographic type of data?
Yeah, absolutely. So Redis and OSS and Valkey also support spatial as the data type. So you can store your latitude, longitude. You can find items near a specific latitude, longitude. So like in a scenarios of maybe ride sharing or even delivery for your groceries or even the food delivery applications, it becomes easy to query whether you're waiting for the car that's nearest to you. So you could store these geospatial data in Valkey and Redis and then use that to kind of retrieve the nearest driver. So that's a supported data type for both ElastiCache if you want to have it semi-durable, or MemoryDB if you want to have it more persistent. You want to store for the entire day. These are the available drivers. These are the available routes. So you could actually use that from MemoryDB as well. Yeah.
In MemoryDB as a serverless option as well, or is it only through provision host that I need to acquire capacity?
No, yes. That is one of the differences between ElastiCache and MemoryDB. MemoryDB at this point is still a fully managed service, but you would have to design your own MemoryDB cluster. So depending upon your dataset size and then the throughput, you can reconfigure the parameters, select the instance size, and then launch and create your cluster. Also launch like a multi-region clusters, but it's still instance or self-design node-based clusters.
I mentioned it already. Due to your position in your role, you see the most complex and the biggest use case coming through you. What are the typical challenges developers are struggling with when adopting in MemoryDB?
Typically, in terms of, I think, what are the scenarios where customers kind of look for assistance is, or we kind of help customers more so is hardware are more instance provisioning scaling. Like when you have an in-memory key value stores, especially Redis and Valkey, which are still under the hood very single-threaded in nature. Like, we've done a lot of performance enhancements into Valkey, added performance improvements into Valkey that kind of helps improve the scale with it helps with a lot of offloading of the tasks with enhanced I/O memory multiplexing, intelligent memory amortization technique. But under the hood, the commands and everything is still single-threaded. So most of the times we kind of help customers architect their clusters for horizontal scalability. That's one of the common kind of patterns that we see. Instead of having one big node, it kind of helps with the scale and performance a lot better if you have multiple nodes, X large to X large, but then have multiple shards. So you're distributing your writes, you're distributing your reads, and gaining that gaining that performance that you would expect from in-memory clusters. And I think that also helps improve the latency and throughput. So helping customers architect their data in a way that it's not all going to a single shard. You have to, distribute your data across keys and then distribute your data that it can be partitioned across nodes. That's kind of one of the aspects that we do help customers on a day-to-day basis, data modeling, that can give them the lowest latency and the throughput that they can achieve with MemoryDB. And of course,
I was thinking while you were talking that history repeats itself, and I remember how we helped customers like a few years ago to optimize for S3 storage using different keys or start of key names so that it optimized the distribution and hence the throughput. It's the exact same story that you're telling now. It's still helping customer to create their shard, to create their partition, to distribute data the best they can, so they can achieve the biggest throughput. That's the main challenge. So availability and performance on one side, and then you mentioned also new data type. We talk about geolocalization data and vector for GenAI. What are the trends? And that will be my last question. So what are the trends you're seeing? We are not going to disclose any roadmap information. We don't do that on AWS, but you're working every day with customers having new demands and probably crazy demands, like crazy in the sense of innovation, good ideas for innovation. So what are the trends you can see for these in-memory database? Because 10 years ago it was a simple quote cache in between the app and the relational database. All the things that you mentioned now, it's like a giant leap from that basic usage. So what will be the conversation we'll have in 10 years?
I think making it far more performant. I think the way the world is going is how we can have better performing and better, more, still higher performance. Like you ask customers, you say that you have microsecond latencies, then microseconds really is like the new millisecond, and eventually my nanoseconds would become the new microsecond. So from improvements that I think the space would see furthermore is improvements in latency, making the ease of deployment even more easier, ease of the other couple of challenges that we do hear customers is like, data ingestions, queries. Do I have to manually maintain all of this? So, making different other AWS service also kind of fit in easier from a scale standpoint. And for the more advances that we see, like, you've seen vectors as one of the advancements that are new data filter types that are added. And this is open source roadmap, so I can talk about it in terms of Valkey. Valkey is an open source community. They have their own roadmap. They publish their roadmap on their own GitHub. And they're looking to add more features into the in-memory key value stores, both ElastiCache, Redis, and then adoption. Just in terms of, if you're using Valkey open source, they're looking to add different data types, different support for, bloom filters, for example. That's something that's coming in. That's actually already part of the Valkey distribution. So those are more adoption, I would see, from different other use cases that are now need the in-memory suite.
That's what I love with Valkey, and before that with Redis open source, is that as a developer, I can really start from my laptop. It's super simple to install and to program against it. And then it scales to this massive scale that you're describing when we need a multi-active, multi-region cluster of machines. That's the type of deployment you can get from AWS. Thank you, Lakshmi. Thank you for describing that world of in-memory database, starting from ElastiCache, and then we talk about in-memory DB as well. You're senior specialist solution architect for in-memory services at AWS. Thank you for having listened to this episode until the end. And now go build.